Hello everyone, this video we are going to cover section 5.4, properties and applications of logarithms. In this section, we have 4 very important formulas. Okay, I'm gonna write those formulas for you. The first formula, log with base b of x plus log with base b of y equals log with base b x times y. This formula or this property is called the product rule of logarithms. If we look at the equation or the formula from the left to the right, we are condensing or we are adding. From left to the right, we are adding two like bases logarithms together. Turns out we're gonna have one logarithm with the same base, keep the base, and the anti of the sum is the product of the original two antis. I think the rule is called the product rule because the anti of the sum happens to be the product of the anti of the first logarithm and anti of the second logarithm. If we look at this formula from the right to the left, we are expanding. If you see the anti-logarithm of the logarithm is a product, you are able to rewrite that logarithm as an addition of two logarithms. The first factor is the anti of the first logarithm. Second factor is the anti of the second logarithm. That is a product rule. Okay? I think our final is open book, so you don't have to worry about remembering formula, but I would recommend you try to remember it. Because we have many versions incorrect formulas in this part. I'm not going to give you any. Sometimes that is kind of misleading. So we're gonna try to just remember the correct version. We are able to subtract or take the difference of two logarithms if they have the same base. The difference is gonna be a logarithm with the same base, and the anti is the quotient of the anti of the first logarithm and the anti of the second logarithm. Be very careful in this case, the order of x and y. Which one goes on the top, which one goes on the bottom? The first anti goes on the top, the second goes on the bottom, okay? If we look at the formula from the right to the left, remember we are expanding. Expanding, I'm talking about this word, expanding, okay? Means if you have a single logarithm and the anti is a quotient, then you are able to rewrite that logarithm as a difference of 2. The formula is called the quotient rule. Number 3. Let's look at this logarithm. Base is b. Anti is x to the power of r. Anti is x to the power of r is an exponentiation. Turns out we are able to move the exponent in the anti in front and multiply by logarithm with base b of x. So I'm saying we are able to move the r in front. Okay? So in this case, from the left to the right, we are expanding. From the right to the left, we are condensing. We're going to have some examples about that later. So from right to the left, if we have a coefficient, a number, multiplied by a logarithm, we actually could put the number back into the anti, be part of the anti on the shoulder of the x. That property is called the power rule. Power rule. Okay? Those three are properties. Number 4, remember I said we have 4 formulas. The fourth formula is called the change of base formula. Change of base formula. If you look at your calculator, you would see log. Okay? Yeah. So what if you see a logarithm without base written out? That means the base is default as 10. A logarithm with base 10 is called a common logarithm. Common. You should be able to find a common logarithm in your calculator. Okay? Log. If you only see log without a base, that means the base is 10. That is a common logarithm. You also see ln in your calculator, right? We talked about this before, earlier. ln is a logarithm with base e, and that is a natural. Yeah. Know those concepts. You're gonna need those in the day quiz. It's called a natural logarithm. We have 2 special logarithms, common and natural. Common with base 10, natural with base e. You are able to see the 2 functions in your calculator. So it means what? It means that if it's a common logarithm or natural logarithm, we would have no problem to evaluate the logarithm, right? Simply just put the value of x there. What if you need to evaluate log with base 2 of 3? Then the calculator wouldn't be able to help you directly. Then you need to do something. Apply the change of base formula. Okay? Yeah, let me write a formula for you first. log with base a of b equals log with base c of b all over log with base c of a. This is a logarithm with base a and anti-b. Turns out you are able to write this log as a quotient of 2 like bases log. Like bases means they have the same base. C could be any positive not equal to 1 number. Any number is okay. On the top, the anti is b. You see what happened here? On the bottom, the anti is a. Yeah, be careful with the water. Which one goes on the top, which one goes on the bottom? So if C equals 10, then we would have log b over log a. Then you use a calculator, you are able to evaluate that logarithm. If you let C be e, you would have natural logarithm of b over natural logarithm of a. Also use your calculator to evaluate for the log. You see what I'm saying? So we use this formula and the calculator to evaluate logarithm if the base is not e, not 10. Yeah. For example, if you need to evaluate the log with base 2 of 3, the example we mentioned earlier, how can you do that? You have 2 options. If you like a common logarithm, you can rewrite this expression as common logarithm of 3 over common logarithm of 2, and use your calculator to find the value. Or if you like to use a natural logarithm, you can rewrite this as a natural logarithm of 3 over natural logarithm of 2. You would see either way you have the same result for this expression. Okay? Yeah. So that is a change of base formula. Yeah, maybe you go back to get more familiar with the first 3 properties. Okay? And change of base formulas. So to get together, this section we have 4 formulas. Together we have 4 formulas. Let's see what kind of examples we have here for 5.4. Expanding and condensing. Okay, so example 1 is to expand. I'll explain what does that mean, expand. Number 1 is log square root x cube over, that is cube, right? Cube over 4 pi to the power of 5. Let me double check. Square root x cube 4 pi to the power of 5. Okay, so anyone see the base? What's the base? You don't see the base, right? That means the base is 10. It's a common logarithm, but it doesn't matter. We're gonna have all the logs involved have a base 10 when we're expanding. What is expanding? We're gonna rewrite this single logarithm as an expression. And in the expression, we have more than one logarithms. And they are in the simplest form. I'm going to show you, okay? Yeah, I will show you how. So firstly, I'm going to rewrite the square root. How do I rewrite the square root? I rewrite it as half. Does that make sense? Okay, this is essential. This step is pretty essential. And then, okay, look at the anti and tell me what's the structure of anti. When I ask the structure means when you look at a building, right? You see the exterior outside the building, right? You're gonna have an idea about the structure of the building, right? Is it 2 floors, 3 floors, what kind of roofs, triangle shape or A shape or dome shape? Yeah. So if you look at this anti, the whole thing here is the anti. What's the structure that you see? Outside structure. Look at the bigger picture. Okay, the answer is a quotient. Oh, sorry, the answer is power. You see a power. The base is inside the parentheses. The exponent is half. Because the structure is a power, we are going to apply power rule. We are going to move the exponent half in front. And then we have log x cube over 4 pi fifths. All right, so that's how do we get rid of the half, the square root here. Okay, so I'm gonna copy half and then use a red parenthesis to hold whatever the expansion for this guy. Now let's look at this logarithm. The anti is inside the parenthesis, right? Tell me again the structure. Now you enter the building. What do you see? Do you see a quotient or do you see a product? Yes, the answer is you see a quotient. Numerator x cube, denominator 4 pi fifths. The structure is a quotient, so we're going to apply quotient rule here. Rewrite that guy as log x cube minus log 4 pi fifths. Okay? So far so good? We apply the quotient rule here. We apply the quotient rule here, alright? Yeah. Keep going, half, and then red parentheses. Let's look at the first logarithm here. The anti is this part. What structure? Power. So we're going to apply power rule. We're going to move 3 in front. We have log x. And continue here. Look at this anti. What's the structure that you see? Product, yes. So you're going to have, let me change the color. I'm going to have a black parenthesis here to hold the expansion of this guy. And is log of 4 plus log of pi fifth. See what I'm saying? Be very careful, use a parenthesis here. because you have a minus in front. If you do not use a parenthesis, you very likely you mess it up. And one more thing, if you see pi fifth, that anti has a structure power, right? Yeah, we could actually apply another power rule here. So let me copy half, copy the red parentheses, copy 3 logx minus the black parentheses. Inside the black parentheses, we have log4 plus, yeah, we're gonna move 5 in front. We are going to move 5 in front. We have 5 times log pi. Almost there. Now we're gonna get rid of the parentheses. The red one, the black one. I'm gonna remove the black one first. 3 logx minus log4 minus, okay, you know how do you distribute, 5 log pi. And then remove the red parentheses. We would have half times 3, 3 over 2 log x, half times -1, negative half, log 4, and then minus 5 over 2 log pi. You know, actually this is good enough, but we can make it even better. 4 is a perfect square itself, right? If we rewrite 4 as 2 square, and that anti is a power, then we could apply power rule to move the 2 in front, the exponent 2 in front. Then we have half times 2 log 2 log pi. So half and 2, half and 2, they cancel each other. So you don't have this part anymore. Okay, of course that's even better. Yeah, so you don't have that part anymore. So the expansion is 3 over 2 log x minus log 2 minus 5 over 2 log pi. Alright, so that's how do we expand. Number 2, continue expanding. This time we have base 3. Anti is inside the parentheses, 27a cubed. When we're expanding, we always observe the structure of the anti. You tell me what's the structure of the anti. Do you see a power? Do you see? Be very careful with the structure. Look at the bigger picture. That is a product, okay? Yeah, 27 times a cube. The cube is on the shoulder of a. Cube doesn't work on 27. So product, we're going to apply product rule. log 3 27 plus log 3 with base 3 of a cube. We know 27 is 3 cube, right? Yeah, for both of them, for both of the two antis, they are powers. So we're going to apply power rule for each. We move the 3 in front, log 3 3, move the 3 in front, the exponent 3 in front, log 3 of a. What is log 3 3? Remember a formula from previous video. I asked you to remember that if the base and the anti are identical, then the logarithm equals 1. Yes, that is 1, okay? This part equals 1. And we have 3 plus 3 log with base 3 of a. And that's the expansion. Okay? Example 2, condensing. We're going to do the other way around. Condensing. If you know what is expanding, then the other way around is condensing. For example, we have log with base 2 of parentheses x squared minus 9 minus log with base 2 with the anti inside the parentheses, which is x plus 3. Okay, so you see an expression. This is a logarithmic expression. We are trying to rewrite the whole expression as one single log. You are looking at a subtraction of two logarithms with the same base 2. So what kind of property you are going to apply? Yeah, look at the formulas. Yes, quotient rule, okay? You're going to keep the base and take the quotient of the two anti. Be very careful which one goes on the top, which one goes on the bottom. The first anti goes on the top. The second anti goes on the bottom. And in this case, numerator could be factored as x plus 3 times x minus 3. And we are able to cancel those two terms, those two factors. And we have log with base 2 of x minus 3. By the way, when we expanding and condensing, we don't worry about the domain. Okay? Yeah, the last part of previous video, I talked about the domain of a logarithmic function. But when we expanding and the condensing, we assume all the domain, we assume all the antis are positive, so we don't have to worry about that. Yeah, we condensed the expression as one single log. Number 2. 2 log with no base. No base means the base is 10, right? Common logarithm. Plus 3 log common logarithm of b minus half common logarithm of c minus common logarithm of d. That's a long expression. We're going to condense it as one single logarithm. All right, let me double check. Did I copy everything correctly? 3 negative half. Okay, yeah. So firstly, this is what I'm going to do, okay? Firstly, I'm going to get rid of all the coefficients. Yeah. By the power rule, I put 2 back on the shoulder of A. By the power rule, I put 3 back on the shoulder of B. And here, I put a half on the shoulder of C. Okay? And then log A squared plus log B cubed. Because I grouped them inside a group, they are both positive. Be familiar with those properties. By the quotient rule, we're going to condense this subtraction as one single log with base 10, and anti is going to be a quotient. This part goes on the top, this anti goes on the bottom. Here we go. Is that clear? Example 3 over log 3 of list over natural logarithm of 1.4. Important thing, using your own calculator and then compare your result with the answer in my notes. So that is a 5.4. Thank you for watching. This 5.3 and 5.4 together is day 20, I believe. Repeat those videos, figure out those contents, and work on your day quiz. Email me if you have any questions. Thank you for watching.